Hello everyone, I'm Chol. Linux cluster on CentOS 6 and 7, Chapter 8, Fencing and Failover Domain, main topics. This chapter will cover this kind of topics. What is the fencing, fencing components, fencing method, how to configure fencing using CCS and Conga, and the concept of the failover domain and the failover priority and mode. Last topic will be how to configure failover domain using CCS and Conga. Okay, what is the fencing? Fencing means the method to separate input output source from each shared storage to ensure data integrity. Normally, we can use the fencing for data integrity. Some the failed node can break this kind of the data integrity. So using the fencing, we can separate this kind of failed node safely for our data integrity. So usually the fencing means the power off the node is a power off. We normally say this one stories. The disconnection of node from the cluster, the shared storage, physically and immediately. So using the physical and immediate disconnection, we can protect our data. A failed node is a fence off from each storage device. 2. We need to prevent this kind of corruption of the resources by using the fencing. And when notified of the failure by the CMan, normally fence daemon will receive this kind of the notification from the CMan cluster manager, and after that this daemon will fence the failed node, and other cluster infrastructure components determine what actions to take after this the successful fencing. How to fence using the fencing component? So first one, fence daemon is a kind of the conference of fencing system. So this fence daemon will receive the fencing request as a service event using the CMan cluster manager. And the fencing agent is a program to interface with a specific type of fencing hardware. So according to your hardware, you have to install the various fence agent. And the fencing program will make a call to fencing the agent specified in the cluster configuration file. So normally if you select the fencing agent, normally this agent will save here cluster configuration file in etc/cluster/cluster.com. And then fencing agent fence this payload via the fencing device. When the fencing is complete, the fencing program notifies the cluster manager, the CMan, and the fencing daemon determines how to fence the failed node by looking up the information in CCS, normally by the CMan. Starting and stopping the fence. So first time, automatically by the CMan service. So like this, config CMan, and you can start the cluster manager service, CMan start or start. If you are successful to start the CMan, normally the C cluster manager will call or start this daemon, the fence daemon agent. So using this command ps-grep fence, you can check this daemon is uploaded or not. And if you want to check the fence, the log file according to your configuration, normally the fence daemons, the log will saved here, var log cluster/fence. Relationship among the fencing, the component. Maybe I already told you the CMan, the cluster manager, will notify the failure of the node, then fence daemon fence the failed node, and the fencing program decide which fencing method. Normally this kind of method will save here, etc cluster.com. And this program will use this kind of fencing method where from this file, etc cluster/cluster.com. So this is a kind of the architecture about the fencing component. Cluster manager, this one will start the fence daemon by the CMan, and this one also will detect this one the failed cluster node. So if this cluster manager detect this kind of failed cluster node, then notify to fencing program. And this kind of fencing program can be run by the fence daemon. And after that, this program will call this fence agent, and the fence agent will use the fencing device to fence this kind of failed cluster node. If the fencing program is successful to fence this kind of failed node, then we'll report the result to cluster manager. This is the architecture of the fencing component. Especially, normally this one will use this the cluster configuration file. Fencing method, there are many kinds of the fencing method. Here, power fencing, normally we say the stories. So this one normally use the power controller to power off. So if power controller power off for the connection with the cluster node, then this node maybe will be separate from cluster. So this kind of normally the cluster node will be the inactive node from network power switch. Storage fencing disable favorite channel port. Cluster node connected to this kind of channel, the switch to exact the port numbers. So connection to storage will be the inactive node here, especially switch or the device like iSCSI. And other fencing method disable input, output, or power of the inactive node using this kind of IBM, BraidPep, DRAC, HP, IBM, and so on. There are many kinds of the fencing method. So this is a kind of the architecture of the power fencing. So this power the fencing agent will connect this kind of power the controller. So power controller is a fencing device, and this power controller will this one, okay, in case of this one, node 3 is inactive node, then this connection will be separate power off. And normally the fencing program will send the command to this kind of power fencing agent. Then this one will control power controller and failed node as well. Favorite channel switch fencing. Normally in this case, the favorite channel switch fencing will use favorite channel this kind of as a fencing device just. And this kind of switch normally will support this kind of connection using the port number. So only in case of this one node 3, then this port will be disabled by this favorite channel switch as a fencing device. And this kind of favorite channel switch connected to this kind of the fencing agent, for example, like fence APC. And this kind of fencing agent will be controlled by the fencing program. This fencing agent and fence program will connect to fencing the device to the fence the specific, especially the failed node, based on this kind of favorite channel switch. Fencing agent, I already told you, this is a program to interface with specific type of fencing hardware, especially device to be customized. And this kind of fencing agent, we can use this kind of fencing agent, the command, and this kind of command normally consists of Perl or Python script. For example, you may install, if you want to use the fencing agent that is system here, you need to install this kind of package, fence agent or fence bud. Fence the bud, this package can be used for especially virtual machines. For example, if we use the CCS-node1 host name and ls fence the options, and this command will show all kinds of fencing the agent we can use. Here, fence _xpn, then this one will show the required and optional options for this fence agent. And after that, you can use like this fence _avm-h. This will mean the help. Then this one will show you how to use this fence agent. If you want to know more the detailed information for this fence agent, then you can use this kind of manual program. Number 3, fence node. This is a kind of command line the utility to run the fence agent as well. So this one too, query the CCS for the proper agent and the parameter to use, and accumulate all the necessary CCS information for input or fencing a particular node. So for particular node, you can use the fencer node to get all kinds of CCS information. And that perform the fencing action, execute the fencing action by issuing a call to proper fencing agent. So for example, this one fence node underbar s node 1, then this one will show the status, and the fence node hyphen the capital U, this one in fence node 01, like this. Fence daemon started by the cement. So if you don't start the cement, then this one will load the fancy daemon and automatically, and the fencing can be performed using this kind of fancy daemon. And this kind of fancy daemon depends on the Siemens cluster membership, the information, and this kind of information for when and what time, or for who to fence which node, like this. And depends on the CCS for how to fence. So when if you use the CCS, maybe anytime you can use the how to the fence for the failed node by this daemon. And the fencing does not occur unless the cluster has the quorum. About the quorum, maybe the next chapter I will explain. So anyway, if the cluster doesn't have enough quorum, then in this case fencing does not occur. What does that work? So when we use the fence, we have to check this cluster has the adequate quorum or not. And the joining fence domain influence being the subject to fencing, and fencing are the domain, the members as well. When we use the fancy daemon, normally we can use this two kinds of options: forced fail delay and forced join delay. So about these two kinds of options, I already explained in the chapter 6. Forced fail delay means the second to wait before apparently the failed node is confirmed the fail, then the fence. So 0 second means 0 means it's default, and if you receive the status code -1, then it means failed node is not the fence. So delay the recovery indefinitely until this kind of failed node rejoins this cluster. Join delay, I already told you this one too. The number of the second fence daemon, this one, wait before fencing a node after the node joined the fence domain. So default is 6 seconds, and the typical setting is 20 to 30 seconds. So fencing command line, the cluster start, I already told you, Siemens start and check the fence daemon. If we want to configure forced fail delay using this daemon, then we can use the option -F. And if we want to use the join delay, then -J. Or you can use the -C, mean the clean start. Clean start means don't fence any nodes at our starting time. Number 2, control fencing daemon manually to join the fence domain. So you can use like this: fence underbar tool, fence underbar tool, join, and wait up to the 10 seconds. If you want to see all the node the fence tool, then ls-n. Number 3, use the fencing agent directly. Normally we will use the command line like a CCS to fence some specific failed node, but according to your situation, you can use your fencing agent directly. For example, fence APIs like a power switch, address this one, and the username and the password. In this case, this kind of policy must supply the username, IP address, and password, and the plugin number, bubbles, and action. In case of action, like we can use the reboot or off or on. Or if we use the XVM based on the KVM, then we can use this kind of the fencing agent. Fencing XVM host name, this one, node03.chol.com. In this case, this fencing agent will fence the node directly. Number 4, the query the CCS for proper fencing agent and option. So if we want to see, or if we want to know the query using the CCS, then you can use the fence node and node information. Number 5, use the cement to kill the specific node. So I already told you, cman_tool also support the fence that failed the specific node like this. Cman tool kill node number, and after that, if you see like this, cman tool the node, you will check this the node is fenced or not. How to configure fence device using CCS. About this one, I already explained in the chapter 6. For example, for our first one, fence daemon property like this. Using this option, the set the fence daemon forced fail delay and join delay. Create the fence device. So in this case, we can create like add fence device. This is the name of the fence device. And after that, this device needs the agent, like this agent and the fence APC. This agent has this kind of required option, IP address, the username, password, this kind of option as well. If we want to delete this kind of fence device, then just we can use RM fence device. If we want to list this kind of fence device and options here, as fence options and the specific, then this one will show all. This option will show the all fence device we can use. And if you put here as a specific the fence agent, then this command will show eject there the fence APC's options. And if you want to see the all information, then get conf. Fencing for cluster members. So now in number 1, I created the fencing device. Now let's use this kind of fencing device for cluster members. Okay, for example, this one, node 1, add method APC. This is the name of the method for specific cluster node like this. My APC means this is the name of the fencing the device. So node 01 will use this fencing device, also fencing method, and this one connected to the port number 1 of this the power switch. And this one to node 2 also is the same, and this one connected to port number 2. If we want to see this kind of configuration, you can use the get conf. Single storage is a similar methoding the name and this one too, and after that fencing device, and this one send is a method, and after that port number like this. If we want to use the unfence mean you need to reboot this kind of fenced node if you want use it again, then we can use this kind of on fence. Fencing for cluster is number C here, failover. Okay, in this case we can use two kinds of fencing method. This one fence method. Okay, APC node 01. We can use the APC for node 1. Also this one node 1 using like a send also like this. But the fencing device is different. This was the APC and this is my fence. And also connected to this one, the 2 port for APC port number 1, for send port number 11. If you want to remove, then like this RM method APC. If you want the insistence for the specific the fencing device like this, you can delete. Failover domain and the restriction. So failover domain means the list of the nodes to which service may be bound. So failover domain related specific the service is working based on clustering environment. Failover domain normally is specified where cluster manager should relocate the failed node the service. So according to the number of the ejected cluster node, you can create your own policy like relocation after failed node service. Normally, the failed domain has this kind of policy, restricted and unrestricted. In case of restricted, the service may only run on node in each domain name. So this kind of domain will include the specific cluster node numbers. If no nodes are available, then service will be stopped. In case of unrestricted, service may run on any cluster node and prefers each domain first. If a service running outside each domain and the domain node becomes available, then service will migrate to that domain node. So I think it is the best way to run this kind of the failover inside this kind of the domain. And exclusive service so may affect the list of nodes available to the service. Using this one, specify the service will only start on node here and which has no other service running. So in this case, maybe only a node can be run. For example, here, this is a cluster client, and this is the clustering with the 4 cluster node and 2 domain. For web server, this one failover, okay, web server, and the node 1, node 2, node 3 will supply this service for cluster client. And for the database domain, node 2, node 3, node 4 will supply their service to a cluster client. For example, if node 1 now supplying the web server service, but this node 1 is a service stop, then this node will fail over this service to node 2. And node 2 also maybe has a problem, then fail over to node 3, like this. Fail over the configuration options. For example, here, we can use this kind of option for failover. So, prefer node. So, mean member designated to run given service if member is online. So, which member is a prefer node? And the restrict, I already explained this one, service bound to domain may only run on cluster member. And this kind of cluster member are also member of the failover domain. Unrestricted, this is a different behavior. If you don't give any specific option, then the failover domain will use this one. So service may run on all the cluster members, but will run on member of the domain whenever on is available. Orders dictate the order of the preference of member within the domain. So when we create this kind of failover domain, normally we need to give eject their preference for each the cluster members. The highest ranking member of the domain will run the service whenever it is online. On orders, default behavior, this one too, have no order to preference. Any member may run the service. Failback, service from members of the ordered failover domain should fail back to the node that it was originally running on before the node failed. So failed node come back. Then in this case, maybe if we use the no failback, then maybe the current node will supply this service until this node is fast. Failover domain prioritization. So here, priority normally so orders and non-priority means the unordered. So each node is assigned the priority. Normally, the first is 1 to 100. So 1 is highest. The lower the priority means the higher service. And the higher priority node are preferred by the service. And if a node high priority the transitions, then the service will migrate to it. And the non-priority normally so unordered. So all cluster nodes have the same priority and may run the service. And the service always migrate to members of their domain whenever possible, especially inside the member of their domain. And any combination of order and unordered and restricted, unrestricted is allowed. In your situation, we can select order or restricted or order unrestricted, unordered or restricted or another unrestricted, like this. Failover mode. So here, normally the failover support two kinds of mode: active, passive failover, and the normally we say the hot standby or active failover mode. So active passive mode, primary node is a running service. For example, this one, okay, this is a primary node. This one running the service, and this is a failover node. So this one normally say is a passive. Other node normally say the passive are just standby in case of failure of the primary node. So if the primary node is a failure, then this passive mode will change to active mode. and provide the consistent quality of the service. Active the mode. All cluster nodes are running each service. So this one, node 1 and node 2 is active mode. So anytime the client requests to node 1, node 2 together. If one server is failed, then the other act as its backup. Node 1 is failed, then node 2 will act like a backup of node 1. How to configure failover domain on CCS. Also, this configuration I explained in chapter 6 as well. First one, how to add failover domain. Add failover domain, for example, like a web server and this kind of option restricted and ordered like this. To add a node to failover domain, so here add failover domain node and the domain name and node number and priority 1, 2, 3. According to your situation, you can give the exact their the priority. And list the failover domain here. List the failover domain. You can see all the failover domain in the list. If you want to delete RM failover domain like this. If you want to remove the eject some the node from failover domain, then RM failover domain name and the failover domain name and node the name like this. Okay, now I explain about the fencing and the failover domain. For the configuration of the fencing and the failover domain in chapter 6 and chapter 7, I already explained using the CCS. So in this lab, I will show you how to configure fencing and the failover domain using Conga. Okay, in my case, in chapter 6, I already consist of this cluster. So cluster name is knowledge peer and with the 3 cluster nodes. So node 1, node 2, node 3 now is working well. And for the testing, I already created the resource for the web server. For example, like this, IP address and the file system and the script like this, and the service group as well. For the service group, now I already using the web service, but this web service here, no default failover domain because I did not create the failover domain for this service. So after I create the failover domain, this web service will use this failover domain. So first, let's go to the failover domain. Okay, add. So here I will create first the web server. Okay, web server and prioritize and restricted and no failover. No failover, I already told you. Do not send the service back to first priority node when it becomes available. Maybe even if the first priority node is come back, but don't need the service to back this the first priority node. So I will use no failover. Remember, node 1, node 2, node 3. Priority 1 and the second 2 and the third 3 like this, and that great. Now I can find failover domain, this one web server and web server showing this kind of option. And I will create one more failover domain here. In my case, database, and this one too, prioritized, restricted, no failover, and member only node 1, node 2. Priority is 10, and the second is 20, and great. Okay, now I created the failover domain and of that in the service group here. So now the web service know what the default failover domain. Then let's go to web service. And here, if you see the failover domain none, but I created the failover domain. So here I will select the web server, and after that, the submit. Okay, so now the change the web server. For the resource and the service groups, I will explain this kind of the topics on when I explain web server clustering the service. When now I create 2 failover domain, web server and the database, and now web service, this service group now using this failover domain. So here, let's check the configuration file for the failover domain. So here, failover domain, web server, and database to the failover domain. And the no failback order and restate is enabled. And node number, this one, node 1, node 2, node 3, and priority 1, 2, 3, like this. And the database as well, no failback order and restricted, priority 10 and priority 20. This one, this failover domain has 2, node only, node 1 and node 2, like this. Here, okay, then let's go to the resource here. Okay, I already told you created the resource here, IP address, this one for the web service, and the file system, and this by script, like this. For this resource, the service, okay, this service will use the web server and the exclusive, this one, web service. Okay, using with these three resources, this source. So web server mean here domain mean the failover domain, this one, okay, coming from here. So if I create this kind of failover domain, I can use like this. So for example, in the service group now, the web service is running now the node 1. But if node 1 is stopped, then the node 1 will fail over this web service to node 2 and node 3, like this. For this kind of testing, in the when I explain web server clustering service, I will explain all these things. So now I create the failover domain, and I use this failover domain for this service group. Now the fence devices. Okay, now let's try to add. So add fence device, and normally we say this one is fence in the instance. So for the instance, so now this high availability system support this kind of the fence device. Okay, if it's power switch was Cisco and Dell, and if power switch fence board, many kinds of the fancy device where the fencing was like this. So in my case here, I will select fence board multicast. So this one, the fence types of fence and the name here, I will use my fence. Okay, the submit. Okay. So now let's try to use this the fencing device in the node. Okay, let's go to the node. So now let's check the each class node. Node 1. In the node 1, if you see the default configuration for node 1, okay, here the property and the port and the receive host and port number. And this node 1 belong to the failover domain, web server and database with this kind of variety. So now here, let's create the fencing method for node 1. Okay, here, in my case, test 1, okay, submit. Then, now I create the test 1, then this kind of the fencing method need the fencing instance. So if you click, in my case, in the fencing device part, I create already the fence, this one, select. And this one need two the option domain, and in case of domain normally we need two the cluster node name, one member name like node 1, and delay option I will use the 10 second. Okay, submit. Okay, now I create fencing the method, and this method include this kind of instance, and the instance means the fencing device. I already created this kind of my fence, and my fence using this fencing agent XVM delay domain like this. Okay, how about the node 2? Okay, this one too now belong to the failover domain and fencing answer. Okay, to this one too, test 1. It's the same, submit. Okay, and add a fence instance. Okay, this one too. Oh, okay. This one is a node 2, and the delay also same. Okay, so okay, node 3 as well. It's the same. So let's fence test 1, submit, add fence instance, SPM, and then this one node 03 and delay 10. Okay, so now I created this kind of fence device here. The name is my fence, and my fence using this XVM, the virtual machine, the fencing. And each cluster node, okay, each cluster node now also using the fencing. In my case, now the default is the fencing message test1, and this test1 include this kind of fencing instance, and this kind of fencing instance with this kind of options as well. Also, I already told you, if you want to the backup fencing device here, you can create or you can add one more the device. For example, like a power switch. But if you select the power switch, you can see this kind of option. So fencing type, the name, IP address, port number, login or password. According to your situation, you can give this kind of options as well. So according to your selection, you can select the exact or the fencing device. So if you select this kind of fencing device, and this kind of fencing device must supply this kind of the information. So to know this kind of information, let's try to use the CCS. Okay, CCS, for example, node 01 ls fence. Then we can find this kind of fencing options for the fencing APC, and there are many kinds of options. So in my case, okay, I select this one, fence XVM. So fence XVM. Then this one is showing this kind of options, the require option and options. In my case, I use here is the domain and the delay like this. And if you want to use this kind of domain, this fencing agent fence xvm-h, okay, like this, then this one will show you the exact options like D, E, H, like this. Maybe if you are using your operating system based on the KVM, then you can use this the fencing agent. And if you want to use this fencing agent directly, then you can use this kind of option H, like this virtual machine. But in my case, I'm using VMware, not the KVM. So even if I use this one, does not work. For example, fence XVM H, like node 03.jar like this. Then if I'm using the KVMM, this one will the fence node 3 direct. But this one now does not work. Okay, now we can see operation the fail. In case of the APC, okay, let's check CCS fence. So this one too, fence the APC. So here optional options like action, IP address, login, and password, like this. So using this information, you can use the fence APC as well. And here, if we use this command, the cluster status, then now node 1 to 3 is online, online, online. And the resource manager also, resource group manager also is working because of that this is service. And now node 1 is the owner of this service and are static. And if you want to, for example, cement tool, and then so now you can see here this is offline. So maybe if we want to fence the specific cluster node using the fencing agent or cement tool, you can use like this. Okay, chapter 8, the summary. So in this chapter, maybe after you start the chapter 8, the fencing and the failover domain, I think you have to make sure the answer about this kind of questions. So what is the fencing? And the second, what kind of fencing conference can we use for the fencing? And what is different between the power fencing and the favorite channel switch fencing? And how can you configure fencing using the CCS and Conga? And what is the failover domain? Can you understand the failover priority and the mode? And how can you configure failover domain using CCS and Conga? Okay, thank you for watching this video, and God bless you. See you in next chapter.